What's going on, grade 11? And in this video, we're going to take a look at the past paper question. And in the question, we've got the resultant force in the horizontal direction, the resultant force in the vertical direction, and lastly, the net force. All right, grade 11, let us begin. I'm going to write question 2 here. Okay, let me read the question. Three forces M, P, and G. These are the forces M, P, and G act at a point O, located at the center, okay, at the origin of the Cartesian plane. The three forces act in the direction shown in the diagram below and are not drawn to scale. It is further given that the magnitude of P and G are 300 newtons and 500 newtons respectively. Okay, we can write here that P equals, okay, P is 300, okay, so 300 newtons, and G equals 500, so G equals 500 newtons respectively. Okay, let me answer the first question. So this one says 2.1, give a reason why the forces are classified as vectors. Okay, from our examination guideline, we know that a vector quantity is a physical quantity that has both magnitude and direction, and that's exactly what I'm going to write here. I'm going to write that they have both a magnitude and direction. Okay, I'm ready to answer the second question. So 2.2, calculate the magnitude of the horizontal component for the force. Okay, so there are sub questions here. So I'm going to write 2.1. Okay, I'm required to calculate the horizontal component of P. I'm going to call that P in X, and this equals P, the magnitude cos of theta, right? And I'm ready to substitute the numbers. So this is going to be the 300 cos of the angle. Okay, the angle has to be the angle between the x-axis or the horizontal axis and the force. Okay, so the angle between P and the x-axis is 20 degrees. So this is going to be cos of 20 degrees, right? And at this point, I'm ready to pull up my calculator. Let me do that and punch in the numbers. So this is going to be 300 cos of 20 degrees, and this gives me 281.91. Okay, so it's going to be 281.91 newtons. Okay, so I've answered the question. So they've asked me to calculate the magnitude, but most of the time we'll also need to include the direction for this one. So I'm interested in showing you how to get the direction for the horizontal or vertical component. The easiest way that I teach in class is using the Cartesian plane. So if you look at where P is, you can see that this is the first quadrant, this is the second quadrant, and this is the third quadrant, and this is the fourth quadrant. We know that in the first quadrant, if I allow me to write here, in the first quadrant, where P is, the Y is upwards, I mean, and X is to the right here. Okay, so if we're looking for P in X, it means the direction is going to be to the right. Okay, so I know that P in X to the right, like that. Okay, so I can move to the next question. So this is going to be 2.2 at G in X. So it's going to be the magnitude of G times cos of theta. Right, if I sub the numbers, this is going to be G. G was given to me as 500, so this is going to be 500 cos of the angle. The angle between G and the horizontal is 50 degrees. Okay, so this is going to be cos of 50 degrees. Okay, I can work out the answer, pull up my calculator and substitute the numbers. Okay, so it's going to be 500 cos of 50. Right, so I get 321.39 So this is 321,39 newtons. Okay, all about the direction. Okay, it is not necessary for me to write it because they want the magnitude, but of course, I'm interested in showing you how to write the direction. Okay, P is in the third quadrant. So let me squeeze this in here. So P is in the third quadrant like this. Okay, this is vector P, right? So what do we know about the third quadrant? We know that X is to the left and Y is downwards in the third quadrant. So if I'm calculating P in X, that's going to be to the left. Okay, so I know that P in, I mean, like, why am I calling this P? It's G in X. Oh my God. Okay, sorry about that. So this is going to be G in X to the left. Okay, so now I can move to the next question. So the resultant of the horizontal components of the force is M, P, and G is 200 and 66,94 newtons. Okay, but before I can move on and do this problem, I just want to show you something. We can plot on a Cartesian plane, right? Let me get rid of this one. Okay, let me get rid of this one. Draw a new one. Okay, we can draw a Cartesian plane like this. Okay, and put X here and put Y here. Right? Of course, this is negative Y and this is negative X. And what I can do, I can now, instead of writing vector M, P, and G, I can write the components of these vectors in the Cartesian plane, meaning I can write the horizontal and vertical component of force M in the Cartesian plane. Likewise, components of P and components of G. Okay, so in the first quadrant, the vertical component of M is going to be upwards. Okay, so I can include this force and call it M in Y. Okay, and also in the vertical, in upwards in the I mean, also I'm going to have P in X here. I mean, sorry, P in Y because P is in the first quadrant, so Y X upwards. All right, I'm also going to have here downwards, I'm going to have G in Y because G is in the third quadrant. So if you look at vector G, so in the third quadrant, Y is downwards. Okay, so now I can move to horizontal vectors or horizontal forces. Okay, to the right here, I'm going to have vector M in X. I'm also going to have a vector P in X. Okay, to the left here, I'm going to have a G in X. Okay, GX, the horizontal component of G to the left, because as you can see on the given diagram, G is in the third quadrant. Okay, so now with this, I can show you that the net force in the horizontal direction is given by a summation of forces in the horizontal direction, which is going to be P in X plus M in X plus K, I'm going to say minus GX here, right? The reason why I'm subtracting or I'm putting a negative sign is because I'm taking vectors to the right as positive and vectors to the left as negative. Okay, so this one is going to have to carry a negative sign. Okay, I can do the same for vectors in Y. So the sum of forces in Y is going to be, as you can see now, this is M in Y plus P in Y plus, and now we're going to subtract this one. So this is negative G in Y. Okay, right. So now in this problem, they've said the magnitude of the horizontal component. I mean, I need to read here. The resultant of the horizontal components, the resultant. So what do they mean by the resultant? The sum of forces in the horizontal direction. This is the sum of forces in X. Okay, is 266.94. So it means the sum of forces in X is 266.94 newtons. Okay, but I just showed you that for the sum of forces in the horizontal direction, we can write the sum of forces in the horizontal direction is P in X plus M in X plus a negative G of X. So it means for what they've given me, I can substitute here 266.94 equals a P in X, which I calculated above here, right? And this is going to be 281.91 plus M in X, right? So M in X is an unknown, okay? Because in fact, this is question 2.3. Okay, they say you must calculate M. Okay, let's go back to the diagram. You can see they've given us the value for P, they've given us the value for G, and they didn't give us the value for M, right? So it means I do not know the magnitude of M in X, but I will keep it as an unknown, okay? And then say plus minus G in X. G in X we calculated there. This is going to be negative 321.39, okay? Now, I can solve for M in X, right? So let me bring the calculator and sorry about that. Let us bring the calculator. So this is going to be now we have to transpose it, and this is going to be 266.94, and we need to say minus 281.91, and we need to add 321.39. Okay, so this gives us 306.42. So this is 306.42 newtons. Right, we know that it is to the right, but we're not going to write it there. Okay, we could, if we like, to the right. Okay, but note this is the horizontal component of X, of M, sorry, this is the horizontal component of M, not yet the magnitude of M. Okay, so we can then say M in X is the magnitude of M cos of the angle theta. Right, so we just calculated that M in X is 306.42 newtons, and this equals M cos of the angle. What is the angle? So let me scroll up. The angle between M, let me use a different color. Let me use a red. So I'm looking for this angle. Remember, I said the angle must be always the angle between the horizontal and the force. In this case, if you look closely, you can see it is not given. Okay, it is not this 20, right? Again, it is not the 30 degrees up. So, but they've given me 30 degrees here because the total is 90. So if I have this angle, this is 90 degrees and M is here, okay? And they've given me 30 degrees here. It means this angle is 60 degrees. So this is the angle that I'm looking for. Okay, the angle between the horizontal and the force, the given force. Okay, so I can go ahead and substitute 60 degrees here. Okay, so this is going to be 60. Now, let me bring the calculator and say 306.42, and I need to divide this by cos of 60 degrees. Okay, so, and this gives me 612.84. So the magnitude of the force M is 612,84 newtons. Okay, so we've answered the question. They asked us to calculate the magnitude of M. Okay, I think I'm ready to find the answer for 2.4. 2.4, they say I must define the resultant force. Okay, so I could say this is a single force. Okay, and having the same effect, as two or more forces acting together. Please note that I'm writing the definition as per our examination guideline. Right, the next question, which happens to be the last question, this is going to be 2.5. Right, they are asking me, let me bring the question. They are asking me to find the resultant or the magnitude of the resultant of the force that acts at point O. Okay, so if we go back to what I said to you, I said we can calculate the sum in X and the sum in Y. All right. Okay, so for you to find the resultant of all the forces that are acting at that point O, what you need the sum in X, which I think has been given to us, and you also need the sum in Y. And these two are going to be always perpendicular to each other, right? So they could be, so I'm sorry about this. So let me erase this. So it could be a situation like this where you have the sum in X and the sum in Y, or if the sum in Y is upwards and the sum in X is to the left. It could be, maybe it could be like this also. So where you have sum in Y and you have a sum in X. All right, so we need to find, because I think this one has been given to us, we need to find the sum in Y. All right, so what we're going to do, we're going to say, okay, what is the magnitude of M in Y? This is going to be M sine theta now. Okay, so the magnitude of M is 612,84. Oops. Let me erase what I just did here. So this is comma 84 sine of the angle. So I did say the angle is 60 degrees, so this is going to be 60 degrees. And let me pull out the calculator, and this is going to be 612,84, right? Sine of 60. Okay, so I'm getting 580,74. So this is 530,74 newtons. What about the direction? I did mention that for you to work out the direction, you need to look at the quadrants. So M is in the first quadrant, so this is going to be acting upwards. I did draw the Cartesian plane there, so this is going to be up. Okay, so we need also a P in X, P in Y, I mean, which is going to be P sine of theta. Okay, so this is going to be a P, the magnitude of P. Let's go back to our diagram, and P is 300. Okay, right, so this is going to be a 300 sine of 20 degrees. Okay, let me just confirm. As you can see, right, the angle between P and the horizontal was 20 degrees there. Okay, so we are correct. So we can pull out the calculator and work out this is the vertical component. So this is 300 sine of 20, and it gives us 102,61. Right, so I think the value is 102.61 newtons. Okay, this is going to be again acting upwards. And lastly, we need to work out a G in Y, so which is going to be G sine of theta, and this let me bring this down. G, the magnitude of G, 500, if I remember correctly. Yes, you can see G is 500. Okay, so this is 500 sine of the angle, and the angle that was given to us is 50 degrees there. You can see it is 50 degrees between G and the horizontal. So we can substitute 50 degrees here. Okay, and let me work out the answer. So we have 500 sine of 50. Okay, so we have 383.02. So this is 383.02 newtons. And again, I did mention that this one is going to act downwards, right? So this is going to be down, right? So the sum in Y now is going to be I nearly wrote X here. Okay, the sum in Y is going to be M in Y plus Py plus, and we're going to subtract this one because it's X downwards. Okay, so this is going to be a Gy. All right, so let me plug in the numbers, and this is going to be a 530.74 plus P in Y is 102.61 plus this is 383.02. Okay, this one must have a negative sign there, and this is going to be, let me pull up my calculator, and this is going to be 530.74 plus 102.61 and minus 383. What's the number there? I can't see what is the number there. And my calculator is blocking my view. So this is comma. Okay, please hold on. 0.02. Okay, so this is 0.02, and I'm getting 250.33. So this is 250.3 newtons. Okay, because the answer came to be positive, and it means this is acting upwards. Okay, and now I can draw the maybe a small diagram to show these two forces. Okay, so it means I can draw it like this. Okay, so this is going to be a sum of forces in Y and the sum of forces in X that was to the right. Okay, a sum of forces in X, because it was given to me as positive anyway, and it X to the right. All right, so now what we can do, we can we try and change the color. We can complete the parallelogram. Okay, so we can sort of draw a dotted lines like this. Okay, and the net force is going to be drawn from the origin as a diagonal. Okay, so we can call it a F net. Okay, so it is clear that this side is also sum of forces in Y. So let me put an arrow there because it is a force also. And we can put the angle theta here, and we get a 90-degree angle there. So from the diagram that I just drew, it is clear that we can apply the theorem of Pythagoras and write F net squared equals the sum of forces in X squared plus the sum of forces in y squared. Okay, I can then substitute and say F net squared equals the sum of forces in x. My, what is it? It was given to me, but I can't remember the value. It was 266.94. Okay, so this is a 266.94 Newton squared plus this one I just calculated here. Here this is 250.33 Newton squared. Okay, so it means if you look at this, I can take the square root on both sides to find the magnitude. So this is going to be 266.94 squared plus 250.33 squared. Okay, let me work out the answer. Let me work out the answer. Okay, here's my calculator. So I need to say the square root of 2. Okay, let me open bracket here. This is going to be 266.94 squared plus open bracket and write 250.33 squared. Okay, this is 365.95. 365.95 newtons. Okay, so let me double check if I've answered all the questions. Yes, I think I've answered all the questions because the last question was calculate the magnitude of the resulting force, which is what I just did. Okay, the 11th, it takes us to the end of our lesson, and thank you for tuning in. Until next time.